Hi everyone and welcome to this new video. So these days I was wondering how the Python interpreter works. So here I'm talking about Python, the well-known Python. Here I can open a shell in Python. I can just print hello world, this kind of Python. I can say a equals 5. I can say a plus a, this kind of Python. So how does the Python interpreter work? And so I thought, okay, let's make a series on understanding doing a deep dive over Python interpretation, and in this first video we're gonna do an initial analysis. So we're gonna see the high-level interpretation loop, we're gonna talk about abstract syntax tree, about Python bytecode, and a little bit about the source code of CPython. So I hope the video is interesting. If you want to support my work, by the way, there's a Patreon. And if you're interested in the testing of web application, in the security testing of web application, I have created a course on web application penetration testing. It's available on Udemy. Thank you for the support and I hope this video gets you something. Okay, so how can we view the Python interpretation loop? So consider the following source code. Here we define a function sum, it takes 2 arguments, and then we return the sum of those arguments. And here we are calling the function, we are assigning the value of this call to the variable x. So x is equal to the sum of 5 and 6, and then we're gonna print out the x value. Like if you take this code, and we interpret it like we do Python 3, I take this code, then it's gonna print 11. Why? Because 5 plus 6 is 11. No shit. Okay, that's good. Now, in order to execute such code, the Python interpreter executes the following steps. So the interpretation loop is divided into the following major steps. Of course, here we could divide it in even further internal steps, but here I'm talking about 3 major steps. So the first one is the parsing, which is when the source code is parsed into an abstract syntax tree. Now, before parsing happens, actually, we have a lexer that tokenizes the input, but I'm not talking about that right now. What I'm talking about is that we go from the source code viewed as a single character to the abstract syntax tree, to a tree, basically. Then the tree is compiled into Python bytecode. That is, we have a compilation into Python bytecode. And these, by the way, are the PYC files that sometimes you see in the PyCache directory. Like if you execute Python, you can have this directory depending on how you configure your system. But this basically is the Python compiled code. And then the bytecode is actually interpreted by the Python virtual machine, by the PVM, that executes the bytecode instruction by instruction. So this is basically what happens when we execute the Python code. Now, to understand more about it, let's break down these steps, because Python actually allows us to view how the AST is constructed, to play around with the AST, and also to see and play around with the bytecode. So first steps, let's talk about abstract syntax tree. So the abstract syntax tree is the representation of the source code after the parsing step. So we can play around with the following code, for example. We can do import ast, the module ast in Python. We can parse the following expression, which is assigning to the variable x the value 2 plus 3, and we are assigning this to the variable 3, so this is the AST, and then we can dump the AST with a certain level of indent. Now, if we execute this code, we're gonna get this output. Now, this output represents the code after the parsing step. So this is the way the Python views this simple assignment operation. So here we have a module with a body. The body is gonna contain this assign statement. The assign statement is going to contain targets and value. In this case, targets is a list of a single variable with a certain name and with a certain context, I believe, is CTX. And then the value is a binary operation where what we have is we have the operation add between the constant 2 and the constant 3. So as you can see, this is a pretty simple operation, but already the abstract syntax tree is a little bit complex. I mean, it's still pretty simple, but as you can see, Python adds a lot of information, and this information are used to then generate the bytecode that is then executed. Now, This is for parsing like a custom expression here. What if you want to parse an arbitrary file? Well, we can write this simple utility in Python. It just uses the AST and the sys module. And here basically we're gonna say, look, if you give me an input through the command line, here I'm gonna open it, I'm gonna read the code, and I'm gonna parse it with the AST module. So basically, this is a very simple utility just to play around with the AST. I suggest you to just play around with it. So how would we use it? Well, here we have the source directory. Here we have this parse.py. Now parse.py is gonna be like, it's just ask us for a script. Let's say here we have a sum script like this one, where we define a function and we also do the assignment. Let's make it simpler. Let's just define a function, for example. Then we can do Python parse3 sum.py. And here we obtain the AST for that particular module, which is just a definition of a function. Notice this body. This body now contains a function definition where the name of the function is sum, and we have the arguments. So we have two arguments with the name arg-a and arg-b. And then we have a body with a return statement with the sum between a and b, basically. So if instead we also put the x equals 5 sum 5 3 and then print x, so we make it a little bit more complex. Now look that the body now contains multiple statements. It contains a function definition, an assignment operation, and an expression. So the function definition is the same as the one that we analyzed previously. The assignment operator here, it takes x as a variable, so the target is x, and the value here is this call to the function sum here with the name sum. So this is how we call a function. We have this call, func name sum, and then we have the arguments with the various constant value 5, 3. And then we have this expression, which is another call, which is the call to the print function with the argument x. So as you can see, basically Python breaks down the code into this tree structure, which is then used to generate the bytecode. And so you can play with this as whoever as you want. I mean, you can really parse any file. For example, let's have this other file. Here we have an assignment, we have an if statement with an expression inside. And here if you just do Python 3 parse tmp, what we find is we have a body with an assignment, an if operator. Within this if operator, we have this compare test, and the body of the operator is an expression. So it's kind of fun because it really allows you to understand how Python internally represents the source code that we write. And so that's a first step into understanding how Python works. Now the next step, however, is that Python does not execute the AST directly. It actually generates a bytecode starting from the AST. So how can we play around with the bytecode instead? Now there are a bunch of different ways in which we can extract the Python bytecode out of a Python file. Here the key idea to have in mind is that we want to play around with this so that we want a way in which we can give a Python function that we can normally write or just a series of expressions, and we want to see the bytecode of those functions and expressions. Now for example, every function that you define in a Python module has its compiled bytecode within the __code __ attribute. So look at this. Here we are importing the this module to have a human readable bytecode. However, if we just want the raw bytecode, we actually don't need that. Here we are defining a function sum, and we are defining it as the sum of a plus b, and this is the raw bytecode of the function sum. We can access it with this statement. Now let's open a shell, for example, down, Python 3. Let's define sum as ab, return a plus b. Okay, so I can use it, like for example, sum 5, 6, I get 11. Now, if we print the sum dot __ code _ dot co _ code, notice I get this bunch of bytes. Now, these bytes actually represent the bytecode of this function that this function is compiled down to. Now, if we want a human readable bytecode instead for learning, we have to import the this module, and you can say this.this, like disassemble, and then we can say the name of the function sum. And here we have the bytecode. So it starts with a resume. It said load fast, binary op, return value. So basically that is the idea. We have these kinds of bytecode instructions. Now the same thing that we did for the AST module, we can also do for the disassemble module. Here we're just reading a script from the command line. We are opening it and we're just like reading the disassemble code. So basically that's the idea. So let's try it. Python 3 bytecode. It's gonna ask for a script. I can say like sum.py, and here I am printing out the bytecode of that function. If the file does not exist, here we generate an exception. So probably we could also try to catch those exceptions in the code, but however, this is like a very simple script just to play around. It's not meant to be robust. So for example, let's go into the TMP. Let's remove everything else. Let's just leave the a = 5 assignment. If I print out the bytecode now, I get a resume, a load const, a store name, and a return const. So basically, that is the bytecode that is executed by the Python virtual machine. If instead I have the conditional statement here, if a = 5, let's do it again. So it's a little bit more complex, right? Because I have resume, load const, store name. Then here I have load name, load const 5. I have a compare operator. I have a pop jump if false. And here I have a jump to L1, and here I have a load name, print, push null, load const. Now, and here L1 is return const. So basically we are skipping, if this is false, we are skipping the internal element of the internal expression of the if statement. And this if statement is gonna basically call the function print with the hello world string, basically. And here we're going to return const because this thing does not return anything, this internal body. And finally, we're going to return const with none regardless. So this is more complex code. If we analyze the bytecode of sum, what do we have here? Sum.py. So sum.py, what we have here, we have load const, we have make function. So here we are creating a function with the sum name. And then we are pretty much saying, okay, load name sum, push null, load const, call, store name. Okay, look here, we're actually loading a code object sum. So here, I would say that we still have to, like this is not the code to define the function itself. To define the function, we will need to enter into this object. So this is just the code to make the function, to call the function here, and to call the print x. So here we are calling the sum with the 5 and 3. Here we are calling the print with the value x. But here we do not actually see the code itself of the function. So basically that's the idea. And so this is just a way in which you can like get started. For example, here we have variable assignment a5 b3. So we have load const and store name. Then we have function calling with the, we have here we load the name, we push null, we load the constant of the argument, and then we call it. Then we say pop top return const. Now this thing, to be honest, I would have to explore more in depth. We can probably do so in one of the future episodes, also if you're interested, of course. Conditional statement, so that was we analyze. We had this pop jump if false, so we have compare, and then like a branching state, a conditional branching, like if this is true or false, we're gonna jump somewhere else in the code. Then we have function definition, where here we are defining a function. Okay, here it says code object sum at blah blah blah, and then it said disassembly of code object sum at blah blah blah. So basically here we have the thing to create a function, and inside here we have the actual bytecode of the function itself, which is a load fast, binary op, and return value. So here we're probably loading some values in some registers, I suppose. Once again, I don't know about that, I'm learning, but it seems like here we are loading the arguments into registers, we are performing the binary operation, and then we are returning the result of that binary operation. So that's the idea. Now, how would we understand this source code, however? How would we understand this bytecode? Well, to do that, we would need to download the CPython source code and read that. So start to read that. Now, what I suggest is, let's just download, for example, the a version of 3.10, for example. So we can just do git clone for that. So we can just do git clone. Okay, let's try to do it. okay, here of course I need the Python URL, otherwise it's not gonna download anything clearly. So I'm just gonna clone the CPython source code, which is of course our point of analysis, is what we want to analyze. And specifically when it comes to the main loop, the main bytecode interpretation loop, we can look at the file python/ceval.c. Now let's wait a little bit. Okay, it downloaded the Python. So we say CPython. Now here, there are a bunch of things. For example, here we have parser, which I believe has to do with how the AST is generated. So notice that this is the biggest file, the parser.c. It is about 34K lines of code, so it's pretty big. And here we have a tokenizer, of course, because in the initially I said we go from the source code to the AST. Actually, this step goes through a tokenizer. So we start from the single characters, we create tokens, and then from the tokens we create the AST. So saying it's just parsing is kind of on a high-level view, as I said earlier. This is not like in detail what happens, but basically when it comes to the parser, we have the tokenizer, of course, and this creates the AST, the AST syntax tree. Then in this folder, we have, for example, the object folder, which deals with the implementation of the different Python object. For example, this is the list object implementation. This is also something that we should analyze in the future to understand how the objects are handled internally by the Python interpreter. So this is the implementation of that. Then we have the Python code of the parser itself, Python. And in here also, by the way, we have the modules. So we have the different modules. For example, the random module we have, right? So this is the random modules that implements the pseudo-random number generator. In this case, this is a Mersenne twister. This is a Mersenne twister configuration, but that's for maybe a different video. It could be interesting. So here we have the different modules of that. But at the end of the day, what I'm interested in today is Python. Now in the Python, here we find the main code for the Python internals, and in particular in ceval.c, we find the main interpretation loop. Now the main interpretation loop is found within the function pyeval eval frame default. So this is the function eval frame default. Now if we go into this function, basically what we can notice is that here we have some initialization, okay? But then, after a while, after this kind of initialization, here we find the meat of the function, which is, so we go down. At some point, we find this switch opcode. Now, switch opcode, the opcode is the instruction that we have to execute, right? Because every virtual machine has a series of opcodes, and opcode encode the instruction and the arguments that need to be, processed during execution. And so, for example, here we find the target nop. In this case, we're just gonna dispatch, like we're not gonna do anything because nop is a no operation opcode. Otherwise, we have load fast, otherwise we have load const, and now internally, this is the way that the single opcodes are implemented by the Python interpreter. Of course, one then we need to understand what does it mean to get local, what does it mean to do all these kind of things. Like I still don't know how it works, but basically when you want to understand how the Python interpreter works, this is where you look. And you're gonna look at the different opcodes, how they're implemented step by step, and then you get the full picture. As I said, step by step. After all, Python is a complex interpreter. For example, this is unary not. So here we have some operation maybe with the stack, because I see a top here. So, it's like complex, but in the future, we can explore more about how these opcodes are implemented. We can maybe explore how the different modules are implemented, like we can play a bit with randomness and things of the sort, how the Python objects are implemented in C, and things similar to that, I would say. Let's just try to understand how Python works to create a deeper understanding over something that we might use for work or for just fun. And I think it's always useful to do a deep dive to try to understand a little bit better how things work. Now, if you're interested in this, you can support me on Patreon, and if you're interested in the testing of web application, I have a course on Udemy. So go and check out that as well and let me know what you think. Having said that, thank you for watching and to the next video.